This week on the show, we are looking at Lumina Desktop 2.0. We have 2 months of KPTI development in SmartOS. We also show you a OpenBSD email service. We have an interview with VLAN-Zezes-ki, which you should look forward to. Nomad Bsd has been released, and John Carmack's programming retreat with OpenBSD is what we mention on this week's episode of BSD Now. BSD Now, episode 238, VLAN-Zezes-ki in hardware. Recorded on the 21st of March, 2018. Hello, I'm Benedict Täuschling, your host.
And I'm Alan June.
So we got a bit of a bumpy title this time, but we have a great interview that you should look forward to. But before we get into that one, we have headlines for you, starting this week with looking at Lumina Desktop 2.0. And you can see on the website, this is, of course, connected with TrueOS, and they have on their blog a outlook into what it's going to look like in Lumina Desktop 2.0. So apparently, a few weeks ago, they started sitting down with lead developer Ken Moore, which we had on the show a couple of times already, of the TrueOS project to get answers to some of the most frequently asked questions about Lumina Desktop from the open source community. So here's what they said on Lumina Desktop 2.0. Do you have a question for Ken and the rest of the team over the TrueOS project? Make sure to read the interview and comment below. They're glad to have your questions, and they could probably do a follow-up of all those questions. So the question for Ken is basically, Lumina Desktop 2.0 is a significant overhaul compared to Lumina 1.x. That's what he said. Almost every single subsystem of the desktop has been streamlined, resulting in a nearly total conversion in many important areas. And with Lumina Desktop 2.0, they will finally achieve their long-term goal of turning Lumina into a complete end-to-end management system for the graphical session and removing all the current runtime dependencies from Lumina 1.x, which is Fluxbox, the X screensaver, and Compton or XComp Manager. The functionality from those utilities is now provided by Lumina Desktop itself, so no more external dependencies there.
Wow, so they're going to have their own screensaver and compositor.
Mm-hmm. Well, that's good to know and to try out, definitely. So going along with the session management changes, they have compressed the entire desktop into a single multi-threaded binary, which means that if any rogue script or tool starts trying to muck about with the memory used by the desktop, which is probably even more relevant now that when they started working on that, the entire desktop session will close or crash rather than allowing a targeted application to crash to bypass the session security mechanisms. And by the same token, this also prevents man-in-the-middle type of attacks because the desktop does not use any sort of external messaging system to communicate. Looking at you, DBus. This also gives a large performance boost to Lumina Desktop. This is kind of an add-on this way. The entire system for how a user settings get saved and loaded has been completely redone completely, and making that a layered setting systems, which allows the default settings in Lumina to get transparently replaced by system settings. So there's operating system, distributor, sysadmin. That's where they are located, which can get replaced by individual user settings, which means, or this results in that the actual changes in the user setting files can be kept to a minimum and allows for a smooth transition between updates to the operating system or desktop. And it allows providing the ability to restrict a user's desktop session based on a system config file to the default system settings and read-only user sessions for certain business applications, so that they only can...
really useful if you're making like a terminal or a kiosk type thing.
Mm-hmm. Yeah, good to have those. The entire graphical interface has been written in QML in order to fully utilize hardware-based GPU acceleration with OpenGL, while the backend logic and management systems are still written entirely in C++. So there's been mostly probably behind the scenes, so people probably won't see those changes, but it's a good change to have in the background. So, which results in blazing fast performance, they say, on the backend systems with a myriad of multi-threaded C++ objects, as well as a smooth and responsive graphical interface with all the bells and whistles, drag and drop, compositing, shading, stuff you would normally find on a desktop. So they got asked, are there any future plans to implement something like Lumina in a Mac jail, which is this is mandatory access control. Yeah. So they said that while they never ran out of Lumina or never ran Lumina in a such jail, they do not see anything on that page which should stop it from running in one right now. So Lumina is already designed to be run as an unprivileged user and is very smart about probing the system to find out what is or what is not available before showing anything to the user. The only thing that comes to mind is that you might get to open up some other system devices so that X11 itself can draw to the desk or the display. Like the graphical desktop environment setup is a bit different than the CLI environment, of course. The next question they got is, they look forward to these changes. They know from last time when they used it, they would scroll and get flashes like the refresh rate was not high enough. Then it would be nice to have a fast system as well, as they know that more of the changes in Linux becoming slower. But not once has it loaded, but in the loading process. It will do another download when these changes come out and install again and maybe stay this time. So if they recall correctly, on the very first versions of Lumina, which is pre 1.0, which is far ahead.
Skip the question.
Oh, sorry. Did I? Oh, then it's probably wrong in the show notes.
Nope.
Oh, this is the overhaul thing, or
Nope.
Isn't it?
Oh, it is wrong in the show notes.
Then you read the question.
It is a missing thing in the show notes. A user was complaining about flickering.
Ah, right. So, and the answer there was...
That was a problem pre-Lumina 1.0.
Yeah.
If you're still seeing it, it's probably a graphics driver problem.
Yeah, and definitely update to the newest one. If that's still happening, you might want to verify that you're using the proper video drivers and that you enabled the compositor with the Lumina settings. Next question is, why was Enlightenment project not considered for TrueOS? It is BSD license and is written in C. The answer was that this was a common question about 4 years ago with the first release of the Lumina desktop, and it basically boiled down to long-term support and reliability of the underlying toolkit. Some of the things they had considered were the cross-platform, cross-architecture support, dependency, reliability, and support framework like Qt5 versus the Enlightenment Foundation libraries, I think, and runtime requirements and dependency tracking like Qt5 is lighter than the EFL and things like that. The plus fact of that is that the EFL specifically states that it is Linux focused and the BSDs are just an afterthought, especially at the time they were doing the evaluation. So,
and the whole point of Lumina is to avoid the situation where BSD is an afterthought and have one where BSD is a first-class citizen and isn't going to have the rug pulled out from under it every couple of months.
Yeah, so that it runs on as many systems as possible without system specifics in there. Okay, there were two follow-up questions. The default layout of Unity, which is the menu bar with actual menu entries on the top and on the side, is one of the few things they liked about the first voyage into non-Windows systems and have been missing since moving on to other distros. However, in 1.4.0 screenshots of Lumina, the OS X-like layout has the menu attached to the window. Will 2.0 be able to have the menus on the bar? And the second one is there any timeline for a public release? Are you taking a when it is ready approach? So the answer to the first one is that in Lumina, you can already put panels on the left and right side of the screen and give you something like the layout of the Unity desktop. The embedded menu system is not available in Lumina because it is not a specification supported by X11 and the window manager standards at the present time. The way that functionality is currently run on Linux is a hacky bypass of the display system, which only really works with the GTK3 and Qt5 toolkits, resulting in a very odd overall desktop behavior in mixed environments where some apps use other graphical toolkits. Yeah, you get that a lot with if you mixed different applications that were not using the same graphics toolkit, basically. And the answer to the second question about the public release date is that they are targeting the 18.06 stable release of TrueOS for Lumina 2, but that is just a guideline, and if necessary, they will push back the release date to allow for additional testing and bug fixing as needed.
Yep.
So, yeah, definitely check out.
Seeing that.
Yeah, look out for announcements about Lumina Desktop being released, and certainly we'll try to get some of the Lumina folks here on the show again, or just give you a little heads up when it's done.
Okay, so our next story is from Alex Wilson, who's an Illumos/SmartOS developer, and he's describing a bit of the journey through the development of the kernel page table isolation patches for Illumos.
AKA Spectre and Meltdown mitigation.
Yes, the mitigations for Spectre v2 and Meltdown.
Mm-hmm.
So the full story is on the blog. I'm going to cut little bits and pieces mostly to make it go faster. But I recommend the version on the blog because it actually tells it as a nice story. Adds some personal flavor and so on. It's good. So it starts on Monday, January 1st. Because as it turns out, on New Year's, people have the day off, I think.
Yeah, typically.
Yes. So he says, on Monday, which is January 1st, I had the day off for New Year's Day, as is usual in most of the Western world. So I slept in late, and Lou, his girlfriend or wife, I don't think he says, anyway, and her friend decided to go to the Wax Museum and see several tourist attractions around San Francisco, and I decided to pass the day just reading. That afternoon, the work chat started talking about a Tumblr post by somebody called Python Sweetness about an Intel hardware security bug. At the time, I definitely did not suspect that this was going to occupy most of my working life for the next 2 months. Like many people who had worked on systems and security, I had read Anders Fogel's post about the negative result in speculative execution research back in July of 2017. At the time, I thought it was an interesting write-up, and I remember being glad that some researchers were looking into this area. I had sent the post to Brian Cantrell and asked him about his thoughts at the time, to which he replied that it would be shocking if they left a way to directly leak out memory in the speculative execution. Yeah, I think you can color most of us pretty shocked.
Welcome to 2018. Yeah.
None of us seriously thought that there would be low-hanging fruit along that research path. But we also felt it was important that there was someone doing work in this area who is committed to public disclosure. Like going forward, at the time, after reading the blog post on Monday, we thought or hoped that the bug might just be a kernel ASLR bypass and wouldn't require a lot of urgency. We tried to reach out to Intel at work and to get more information, but we were met with silence. It turns out we wouldn't hear back from them until they had disclosed everything publicly. The speculation on Tuesday intensified until finally on Wednesday morning, I arrived at the office to find links to late Tuesday night tweets revealing exploits that allowed arbitrary kernel memory reads. I saw some of those where it's like reading the password out of your Firefox as you're typing it into the website and so on. It's like, oh, look, I can steal passwords from your password manager.
That's not good.
So Wednesday was not a happy day. Intel finally responded to our emails after they had already initiated public disclosure. We all spent a lot of time reading. An arbitrary kernel memory read, which is just an info leak, is not that uncommon as far as bugs go, but for the most part, they tend to be fairly easy to fix. Just make sure that bit of memory doesn't get copied out to userland or whatever. The thing that makes the Meltdown and Spectre bugs particularly notable is that in order to mitigate these, a large amount of change is required in very deep, low-level parts of the kernel. The kind of parts of the kernel where there are 20-year-old errata workarounds and where single-line changes that you have to be very careful not to accidentally undo. The kind of parts where, as they say, mortals fear to tread. Yeah. So by Friday, the Illumos people had seen patches from Matthew Dillon of Dragonfly BSD for the first time. These were the first patches for kernel PTI that were very straightforward to read and understand, and applied to a BSD-derived kernel that was more similar to what they were accustomed to working with than the Linux patches. To mitigate Meltdown, and partially one of the Spectre variants, you have to make sure that speculative execution cannot reach any sensitive data when it's in a user context. This basically means that the pages the kernel used for everything potentially sensitive have to be unmapped when you're running user code. And this is where the performance penalty comes from, because you have to unmap it, run in user mode, switch back to kernel mode, remap it all, run, and then back and forth and back and forth. Especially when, you can go back and forth, millions of times a second. And so doing all that work every time slows things down.
Yep.
And basically limits how many million times you can go back and forth in 1 second. Anyway, traditionally, CPUs that were built to run for multi-user operating systems did this by default. They would unmap the kernel for you. And that's where Spark, as an example of such a CPU that has a completely separate address space for the kernel and the user land. However, x86 descends from a single address space microcontroller and has grown up trying to avoid backwards incompatible changes, and that thus has never really introduced a clean notion of multiple address spaces. Although it has segmentation, which is the closest feature, but that was thrown away when we went to 64-bit AMD 64 architecture. Instead, operating systems for x86 have generally wound up, at least in the post-AMD 64 era, with flat address models where the kernel text and data is always present in the page table, no matter whether you're in user mode or kernel mode. The kernel mappings simply have the supervisor bit set on them so that the user code can't directly access them. And the CPU is supposed to enforce things for us, but it turns out it doesn't always do that. So the mitigation is basically to stop doing this, to stop mapping the kernel text, data, and other memory into the page table when we're running in userland. Unfortunately, the x86 design does not make this easy. In order to be able to take interrupts or traps, the CPU has to be able to have access to a number of structures mapped at the current page table at all times. There's also no ability to tell an x86 CPU that you want it to switch page tables when an interrupt occurs. So that if you're in user land, if the CPU had this feature, it would say, oh, I have an interrupt, let me switch to the kernel page table so that this interrupt can actually happen. But that's not a thing in x86. So the code that we jump to when we take the interrupt, as well as having space for a stack to push context into, has to be able to access both page tables. And finally, of course, we need to be able to figure out what other page tables there are that we should switch to when it's time to enter the kernel.
Right.
So when we look at the patches for Linux and also for Dragonfly on Friday and started asking questions, it became pretty evident that the initial work done by both was done under time constraints. Both had left the full kernel text mapped on both page tables, and the Linux trampoline design seemed overcomplex. So Alex started looking over some ideas with Robert Mustachi about ways to fix these and who we could talk to about it and reach out to. And so Alex reached out to some of his old workmates from the University of Queensland who were involved in OpenBSD. It seems to me that the OpenBSD developers would care about these issues even more than we did and would want to work out how to get the mitigations right. So Alex says, I ended up sending an email to Philip Guenther, or Guenther? How do you pronounce that?
Günther, yeah.
Okay, Guenther.
Yeah,
on
enough.
Friday afternoon, and on Saturday morning, I drove an hour or so to meet up with him for coffee at a coffee shop. And they talked page tables and interrupt trampolines. We wound up spending 6 hours at the coffee shop, and I came back with several pages of notes and a half-decent idea of the shape of the work to come. But one detail we missed that day was the interaction of per CPU structures with per process page tables. much of the interrupt trampoline work is most easily done by using per CPU structures in memory, and you define, or because you want a per CPU stack. If you combine that with per process page tables, however, you have a problem. If you leave all of the per CPU areas mapped for all the processes, you can leak information via Meltdown about the state of one process to a different one when taking an interrupt. In particular, you can leak information like the instruction pointer, which ruins all the work done by position-independent executables and ASLR. So there are two options. You can either allocate the per CPU structures per process, but then you end up with number of CPUs times number of processes tables, which can get pretty big, with machines with 64 or 96 processors now, and then hundreds of processes. Or you can make your page tables be per CPU. OpenBSD, like Linux and a bunch of other implementations so far, decided to go down the route of per CPU per process pages to solve this issue. Whereas for Lumos, we took the other route. In Lumos, it turned out that we already had per CPU page tables. Robert and Alex rediscovered this on a Sunday of that week. It turns out we used them for 32-bit processes that were running on a 64-bit machine. Because the amount of physical memory is greater than the amount of virtual memory, we used the PAE extension support in our kernel, which, as it turns out, is relatively uncommon among open source operating systems. The logic to deal with creating and managing them and then updating them was already written. And after reading the code, we concluded we could basically make a few small changes and reuse that instead of having to start from scratch.
Oh, good.
By the end of the second week, we had a prototype that could boot all the way up to userland. But when working on this kind of kernel change, we have a rule of thumb that we use. After the first 70% of the patch is done and you can boot again, now it's time for the second 70% of the patch.
Yeah.
Of course, in fact, it turned out to be more like the second 200% of the patch. Yeah, a tedious long tail of bugs to solve and end up necessitating more changes to the design as well. So then you're back working on the first 70% again. So
That's how you reach 2 months.
Yeah. So at first we borrowed the method that Matt Dillon had used on Dragonfly by putting the temporary stack space and the state data for the interrupt trampolines into an extra page tacked onto the end of the GS register, which in Lumos is the structure CPU_T. But if you read the existing logic and the interrupt handlers for dealing with the GS register, you will quickly notice that the corner cases start to build up. There are a bunch of situations where the kernel temporarily alters GS, and some of the different ways to mess it up. If you mess it up, there are security consequences that end up being worse than the bugs they were trying to fix. So as it turns out, there are no less than 3 different ways that the ISRs used to try to get to having the right CPU-T structure in GS in Lumos. And as it turns out, they're all subtly different. Trying to tell which you should use when also requires a branch to test logic, and that in turn requires branches and changes to CPU state, and the whole point is to try to avoid that during the trampoline. So Alex kept in touch with Philip Gunther and Mike Larkin from OpenBSD throughout the weeks that followed. In one of the discussions we talked about the NMI, or non-masking interrupts, and MCE, which is machine check exception, handlers, because I know those definitely came up as things that needed to be looked at in the FreeBSD stuff during development. I don't know what the final disposition of those was, though.
Okay.
Anyway, and the fact that they're currently handled on OpenBSD, or the current handling on OpenBSD, neglected some nasty corner cases around interrupting an existing trap handler. So it's going through a trap right now, and then an interrupt comes up and interrupts that, and you end up 2 levels deep. A big part of the solution to these issues was to use a feature called IST, which allows you to unconditionally change stacks when you take an interrupt. So traditionally on an x86, only changes to the stack pointer, or RSP on AMD64, while taking an interrupt when there's a privilege level change. Right? So it only changes the stack pointer if you're going from one privilege level to another. If you take an interrupt while you're already in the kernel, the CPU does not change the stack pointer and simply pushes the interrupt stack frame into the stack you're already using. However, with the IST feature, it makes the change to the stack pointer unconditional. You always switch to a different stack. If used unwisely, this is a bad idea. If you stay on that stack and turn interrupts back on, you can end up with another interrupt and clobber the frame that you're using. However, in it, I saw a possible way to simplify the KPTI trampoline logic and avoid having to modify the GS register. Anyway, a few weeks into the project, John Levon joined us at work. He had previously worked on a bunch of the Zen-related stuff, as well as other parts of the kernel very close to where we were. So we quickly got up to speed on the KPTI work as well. He and I drafted out a crazy idea on the whiteboard one afternoon where we would use the IST feature for all interrupts on the system and put the stack they used in the KPTI page at the end of CPU-T. Then we could easily use the stack relative addresses to get the page table to change to, so we'd know which one to use, then pivot the stack to the real kernel stack in memory and throw away most of the conditional logic. A few days later, we had convinced each other that this was the way to go. However, two of the most annoying issues that we had to deal with was the sysenter instruction on x86. This instruction is used to make a fast system call on 32-bit userlands. It has a couple of unfortunate properties. First, it doesn't save or restore the R flags, so the kernel has to take care of that itself and be careful not to clobber it when you're saving and restoring. And secondly, if you execute sysenter with the trap single step flag set, say because of a debugger, the resulting debug trap frame points at kernel code instead of user code where it actually happens. And the first one requires some very careful gymnastics on the entry and return trampolines, specifically for sysenter. Well, the second one is a nasty case that it is incidentally made easier by using the IST feature. And they go on about making debug easier and so on. And then they say, it's been a long and busy 2 months and a lot of time spent building, testing, and validating the code. We've run it on as many different kinds of machines as we could get our hands on to try to make sure we catch any issues. The time we spent on this has been validated several times in the process by finding bugs that could have been really nasty in production. So they have a great example of that, actually. Their patches, when run on a Westmere EP Xeon, which I think I have a bunch of, were causing busy machines to throw a lot of level 0 instruction cache parity errors. This seemed very mysterious at first, and it took us a few times seeing it to believe that it was actually their fault. And this was actually caused by the CPU accidentally activating an errata for the Westmere, number B52, memory aliasing of code pages may cause unpredictable system behavior. As it turned out, we had made a typo and put the cacheable flag into a variable called flags instead of attributes, where it belonged and when setting up the page table. This was causing performance degradation on all other machines, but people weren't noticing. But on the Westmere, it actually caused cache parity errors, which would made it more obvious, and they were able to find this bug that, this is a great example of the surprising consequences of small mistakes in this kind of code can end up with. In the end, I'm glad that the errata actually existed. Otherwise, it might have been a long time before we actually caught this mistake causing a performance problem on every machine. So when they wrote this article, they say, as of this week, Mike and Philip have committed the OpenBSD patches for KPTI to their repository, and the patches for Lumos are currently up for review. It's a nice kind of symmetry that the two projects who started on the work together after the public disclosure at the same time are both almost ready to ship at the same time in the end. I'm feeling hopeful and looking forward to further collaborations like this one with our cousins, the BSDs.
Yes, certainly. I mean, just looking at what other operating systems in the open source space are doing, like looking at or talking to the OpenBSD folks for 6 hours, or looking at what Dragonfly is doing, this is exactly what you want to have in like doing not just, oh, I'm the only operating system in the world, I'm not looking left and right. Learning from the other people and even extend their patches if you find something in there, and collaborate, contribute.
In this particular case, KPTI is very specific to each kernel, so there's only concepts that could be taken, but it's definitely interesting to just see the contrast between the different implementations as well.
Yep.
And in the meantime, I think it was last week on March 12th, the Lumos stuff actually landed.
Ah, excellent.
They're committed into the Lumos joint branch anyway. I don't know if it's actually in Lumos gate yet, but the patches are there up on GitHub if you want to take a look at them.
Yeah, and I mean, it needs a long breath to work on these. I mean, for 2 months, even just analyzing and finding where the errors are and how the fix should look like is definitely taking a lot of effort.
Well, yeah, like with a bunch of this, it was like, well, nobody knows what the right way to solve this is yet.
How can we get this done properly?
Yes, there's a very large time crunch, especially with Joint being a public cloud provider. And at the same time, there's not a guidebook on how to do this right. It's blazing a path. This week's episode of BSD Now is brought to you by IX Systems. Head over to ixsystems.com and check out their ultimate guide to buying a new server for open source.
Yeah, that's what you can get there. These contain a bunch of questions you should ask your other vendors, whether they provide the same kind of level as IX Systems do. And you certainly, within the first few questions, you will find that they don't. And IX Systems is the one where you should get your hardware from, whether it's a small or comparatively small FreeNAS Mini or Mini XL for your home or office use for your backup purposes, up to the big storage systems, even the all-flash systems, or even the true rack, the biggest ones they have. This is certainly something where you get the most money or the most bang for your buck out of those, because you can tell the IX Systems folks, I want to run this certain application. I want to run this distributed database. I want to run certain applications in the open source space. Can you build me a server just for that? That gives me the right performance, has the right, backup strategy, for example, if you're dealing with a lot of files and need to back those up properly, or if you want to hit a certain performance measurement, being it memory or in the CPU space.
Well, it's more that with IX, they can help you build the whole system, not just the individual machines.
Right.
But like with the True Rack, it's about getting the right amount of storage, the right amount of compute resources, and making it all work together.
As a whole.
Or, for my company, it was, we need to build this custom appliance that we need to be able to quickly build as we need, just in time, and ship them to remote data centers, but also be able to build a version we can install at a customer site. And then our storage needs are special. I turn out to be really picky about storage and how it's done. And I needed somebody that could help me build the right system so I could grow it as I needed it. And IX did that. And not only that, but allowed me to grow my storage as I need it. And so I'm sitting over here hitting refresh on a FedEx page, waiting for my 32 12 terabyte disks, which should arrive tomorrow.
Mm-hmm. You can also find IX Systems at a lot of trade shows or open source events. The recent one they have on their blog is Scale, which is the Southern California Linux Expo, where they had a table and where you can find a lot of the information that you would need if you're still not sure whether you want to buy from them. They have people and a lot of systems there to demo in case you want to talk to a couple of people before you're making a buying decision. So check out those blog posts where they always not only connect with the open source world, because some of their or most of their solutions are based on open source like ZFS, but they also present what kind of cool stuff they have in the hardware or what they can build you.
Yep.
So yeah, check out IX Systems and definitely check out ixsystems.com/BSD Now, the server buying guide for open source. Okay, next up we have an OpenBSD email service, which sounds interesting, considering that email has been around for a while. But with OpenBSD on top of that makes it even more interesting. So this is kind of an email provider.
Well, this is a set of tools for you to do it yourself.
Ah, excellent. Even better. So this is over at GitHub, and you can find there that this is still in beta, but already has some compelling features. It starts with that it has an efficient or it's actually efficient. It's configured to run on a minimum of 512 megabytes of RAM, so a small system could even power that, and a 20 gig SSD, so that's all that's needed. Could run in a KVM or in a cloud provider VPS or similar things for around $2.5 per month.
Yeah, between $2.50 and $5 a month, you can get a VM with these specs or better and run this in it, and you can. It can store about 15 gigabytes of uncompressed mail-dir's, which rivals whatever you can get from a free provider. And you can always grow the SSD at the cloud provider and pay a little bit more and get more space. It includes email messages being gzipped. So with the default level of 6, you can save another 30% of the space, or make more mail fit on the same amount of space. It includes server-side full-text search, including headers and body, so that you can index all your mail and be able to search it quickly, even from your phone. It's mobile data friendly. It supports IMAP over TLS and with compression, so that it will not eat up your mobile bandwidth. It supports subdirectory tags and filters, so you can monitor your email addresses and pre-sort incoming email. It supports virtual domains, aliases, and credentials in files or Berkeley databases or SQLite. So you can, whatever makes most sense for you as far as managing the different users. If it's your personal email and you have 2 accounts, then you can use a text file, but you can also use a Berkeley DB or SQLite if you need to host many domains with many users. It supports naive Bayesian filters like rspamd, filtering with supervised learning, the lowest false positive spam detection rates you can get. It includes carefree automated spam and trash cleaning services. So anything that goes in your trash or spam folder is automatically deleted after 30 days. So you don't have to remember to manually empty it to not run out of space. But you can always get your stuff back if you look for it before it's been gone in trash for 30 days. Includes automatic quota management to gently assist you when you're over a quota and so on. There's an easy backup MX setup using the same configuration installed in minutes on a second host, so you can have a backup MX. Includes worry-free automated master-master replication with the backup MX, so that your email is always in 2 places instead of just 1. And it's resilient. The backup MX can be used as a primary even when the primary is not down. So you get 2 perfect replicas. And it's flexible. It's easy to switch roles between primary and backup and so on. And if you need to switch VPS providers or just get a fresh machine or whatever, just install it on the other one as a backup, then flip it to be the primary, and then you can take down the other one and so on. And it works like that. It supports all the latest features, including DMARC, DKIM, and SPF, so your email validation and prevent spoofing. includes a daily Spartan stat report so that you can keep track of things, and all Civ scripts and managed Civ configurations are there, so you can just get started.
Yeah, and further down you have the Getting Started guide where you can see what's needed to get this stuff up and running. That seems pretty straightforward here.
It'd be interesting to look at doing this on FreeBSD with ZFS, because then you can have snapshots and replication of the mailders that way.
On top of that, yeah. Yeah, certainly. If we have someone out there who is interested in running this or has been running this already, then definitely send us a little report or a blog post maybe to feedback@bsdnow.tv, and we'll cover it in a future episode.
Yeah, it looks like most of even the instructions here should work pretty straightforward on FreeBSD. I think one or two of the package names is slightly different or something, but in general, all these tools are pretty standard and will work on any operating system.
Yep, but it's good to have them in a one document where you don't have to browse the internet to, how do I do this thing and that other thing? Yeah, good write-up, and if you're interested, then try it out. So we have an interview this week with VLAN-Zezes-ki. So first of all, welcome to the show.
Thank you. Here.
Our first question we always ask people who haven't been here on the show before: how did you get first introduced to Unix, or in your case, Illumos SmartOS?
Yeah, well, I mean, SmartOS inherits from Unix, so I think that's it counts there. It's actually kind of funny because my first introduction to Unix was Solaris proper, probably in 2005 at my first job. And I did not like Solaris at all back then. But that's probably because I came up on a Windows background. I had a Commodore 64 when I was younger. And then after that, I had a PC with Windows 3.1. So I was not exposed to Unix early. It was actually much later in life. So I came to my first job and I was still using Windows for development. And then of came under the tutelage of their senior developer at this first job, and he kind of taught me the ways of Unix and Emacs. I ended up liking Linux a lot, and then but we were using Solaris at the company for various things, and I kept trying to take my Linux knowledge into Solaris, and it just didn't work. So at first, I really did not like Solaris at all. I always wanted to be on Linux, and then fast forward to, 2013 maybe, 2012. I can't really remember, when Joyent introduced SmartOS to the world. I was working at Basho on the React database at the time, and two of my coworkers had seen the SmartOS release, and they're like, hey, let's check it out, because it's meant for these zones. It's meant for containers, and maybe we can use that for testing. Because we were working on a distributed database. So they kind of, forged ahead and pioneered how to use SmartOS at Basho. And I started looking at the wiki page and found it kind of interesting. So I'm like, hey, I'm just going to try running it. And I just ended up falling in love with SmartOS. I really liked the tooling it provided. I think initially my fascination was that it was so easy for me to stand up zones, like containers, not hardware virtualization, and test React, as a 4 or 8 node cluster, versus if I used hardware virtualization, I couldn't really fit that many nodes on my host. So, and it allowed me to test without having, to go to AWS or some cloud provider, which was costly and time consuming. So I think that's really what got me into it was using zones to test React is kind of how I was initiated into Unix.
Oh, that's interesting. Yeah.
Mm-hmm. So how did you get started contributing to open source?
So contributing to open source is related. That was Basho. So I was at AOL at the time. I worked at AOL from 2008 until 2011. And at AOL, I was actually at the company advertising.com, which was a subsidiary of AOL that they purchased. And advertising.com's big thing was, advertising, bidding on, I forget what they called it, but, like the square in the website where you place the media, they were bidding on that property. And so the big thing at advertising.com, what made them so popular is they were really good at making the correct bids for the customers. And the bids were determined by a very sophisticated, control signal loop that was written over in California by a bunch of PhDs. And their code was great. They could predict the winning bids a lot of the time, the least amount of money to get the winning bid. But they weren't great at taking their code into production. So I was on the team that was tasked with getting that code running in production. And so I had come into this project. It had already started, and it was a C# application because at some point someone at AOL had decided everyone needs to work in .NET. So this mandate, it was horrible. This mandate came from on top, and so everyone had to work in C#. And I had, at that time, come from a Java background. I knew Java fairly well. I knew the JVM a little bit. So it was kind of similar, but C# was a fairly gigantic language already at the time. I didn't like it. And so what they had built was they had this distributed system to serve these bids. And it was a 50-node cluster all running this C# application. And it was all on Windows. And using whatever that Windows web server is, I forget the name of it.
IIS?
Yes, that's it. That was horrible. And COM objects and all this Windows junk that I've kind of purged from my brain. But yeah, so they had the C# application. It was 134,000 lines of code. And it was an absolute mess. And the longest it would run was for several hours, and it would just come crashing down. And if you wanted to debug anything, you had to log into a Windows machine with VNC and use these GUIs, and none of it made any sense to me. And I was really big into functional programming at the time, so the mentor I had at my first job was also at AOL, and he's like, "Hey, why don't you check out this language called Erlang?" And I just started reading up on Erlang, and I just kind of fell in love with it. And I was looking at the problem we were trying to solve, and I'm like, well, this is a distributed application. Erlang's very good at that, and Erlang's also a language where I can express ideas much more concisely. So long story short, I basically rewrote a 134,000-line C# application in 4,500 lines of Erlang, and I did in 5 nodes what they couldn't do in 50. And I did that with React. So getting back to how did I get into open source? So I used React for this. And React, I tried CouchDB at the time. I tried BigCouch, which was a Dynamo clone built on top of CouchDB. I tried a couple of other distributed databases at the time, which I forget. I didn't try Cassandra at the time. I'm not sure why, but I knew about it. I didn't use Mongo, probably for the obvious reasons, even though Mongo was super hot at this time, right? Everyone was up on Mongo, but I just got a bad feeling about it. So I went to React, and it proved to work very well. And so I just started contributing patches to React, and they took notice of the work I was contributing, and AOL just became more political around this project, and there were acts. They let go of 4,500 people, and I'd always wanted to kind of work on an open source project. So I said, you know what, I'm going to go ahead and cut ties with AOL and take a chance and go work at Basho. So that's my very long story of how I got into open source.
Yeah, that's an interesting one. I mean, not many people would think about running or rewriting such an application out of a whim, just trying out whether another language is better at solving that.
I was younger. I was younger. That's a bit of a young man's thing to do. I feel like I probably wouldn't do that today. I feel like that's not a very good team thing to do. But back then I was very hungry, and I was just very dismayed by the fact that no one seemed to care that this application wasn't working, and it was so complicated. And I just, I decided to go off and go a little rogue. So it worked out, but I probably would try not to do that these days.
Yeah, it's also probably going to start a lot of politics and meetings just about this stuff.
Oh, yeah. Yeah, there was, wow, I caused quite a disruption at the company. I was not popular with certain people with the title of architect who were not very happy with me. So, because I was just a little, developer. So.
Yeah, newcomer. So I guess this next question is already a bit answered already. So what sorts of things have you worked on in the past besides this?
Yeah, so I mean, before I did React, I worked at a company called eOriginal, which does electronic document origination, which back in 2005 was still kind of up and coming. I don't know if you've ever used those like very horrible Topaz digital signature pads. They're like, you can't actually see what you're writing. They're kind of a first iteration. So I kind of worked on those a little bit, and I worked on what was called an eVault, which is a way to store your electronic documents, and they could hold up in court as originals. And it was basically a very atrocious 550,000 line J2EE application. So that's how I cut my teeth in professional programming, was very large Java applications. And then I went to AOL and kind of went over that story. And then I went to Basho, where I was one of the core developers of React for about 3.5 years. And I developed an integration between React and Solr so that you could better search for your React objects. That was one of the key weaknesses we had with React was, as a key value store, we were phenomenal, but the ability to find your data through means other than the primary key was a bit poor. So I kind of wanted to solve that with Solr, and so I worked on that for a number of years, and that was a lot of fun, and I learned a lot there, and I obviously became an Erlang expert, but then I kind of burnt out on all that. Working on databases is not fun. It's not easy. Yeah.
Certain databases.
Yeah, it's tough. I mean, there is so much competition out there, and the landscape keeps changing. Every year, there's just these new great papers coming out that just find new ways to store data, to retrieve data, and it's fascinating. It's a fascinating field, and I applaud anyone who works on it, especially when you talk about the distributed systems aspect of databases. If I have multiple replicas on multiple machines, and some of those machines are down, how do I resolve this? Do I give maybe incorrect data? Do I refuse the request and give no data? What do I do when the machines come back up? How, things like CRDTs and dealing with merge issues. It's all super hairy, and I got a little bit burnt out on it. Honestly, there's people in that field that are far smarter than me. And I just felt like this wasn't my jam. So I took 6 months off of work. Once again, kind of a young man's decision. I was like, hey, I have a bunch of savings. I'm just going to not work for 6 months. Probably wouldn't do that again either. Well, I would do it because it was a good break, but I money-wise, it wasn't the smartest idea. But
sure.
So yeah, I took off work for 6 months, and I was like, I love lower level stuff. I am fascinated by operating systems. I kind of got gypped in college. My operating systems class was pretty horrible. So I'm like, you know what? I'm just going to learn this stuff and see where it goes. And so I bought Solaris internals and just started plugging away. Just started like picking features and being like, all right, I'm going to read this code until I kind of understand how it works. So yeah, and then, so now I've been working, I'd say for the last 3 years or more, I've been working on SmartOS, which inherits from Illumos, which was a fork of Open Solaris, which came from Solaris, which came from version 7. Well, it came from SVR4, but it has heritage all the way back to original Unix, just like BSD. And there's old copyrights in the code to prove it. If anyone doesn't believe it, you can go in there and see some very old copyrights and some very old hairy code, which is kind of fascinating. I kind of love that I can, in the code I work in on a daily basis has copyrights from 40 years ago. I think that that's a testament to the strength of Unix and its lasting power. I'm very appreciative that I get the chance to contribute to that, because so many great people have been part of it, and now I get to take a small part in it myself.
Yeah. And I'm coming back to your earlier things that you mentioned, is that some of these things in the distributed databases are basically the same problems you have to solve in operating systems, because they're just sitting on top of that. And so
I agree. I think, so one of them, the problem of what's the correct data, that exists in multi-package systems, so multiple physical CPUs have to have, cache coherency protocols to determine, so when you do a read of this value from the cache, am I getting the correct value, which is very important for the correctness of your system. And it gets very hairy down there. And if you look at it, a lot of what they talk about is very similar to getting the correct value in a distributed database. The main difference being the failure modes are very different, and the latency is very different. But other than that, they're the same problem. I completely agree.
Yeah, especially with the newer scalable CPUs starting to look more like a network, actually, between the different components of the CPU and so on. Actually, like a packet switch network between them. It's becoming a mini distributed database inside the chip.
It's crazy. And I haven't really kept up with any of the chip stuff. Lately I've been, and I guess we'll talk about it in a little bit, but just a little bit right now. I've been working on stuff related to NICs, and modern NICs have very complicated controllers with a lot of functionality, and there's just more and more that you have to understand to correctly deal with hardware. So it's it's kind of fascinating and cool, but it's also very scary, because there's just so much that can go wrong. And I think Meltdown was kind of a good example of this, and all these new side channel attacks coming out. These chips are no longer simple things. They're very complicated, and there's a lot of different states you can get them in, and we don't necessarily know what happens in all those different states.
Yeah. Well, just wait till you see the 100 gig NICs.
No, I don't even want to know. I'm up to the 40 gig so far. I don't even want to know what the 100 gig manuals look like.
Yeah. So can you tell us a little bit about what attracted you to Illumos and SmartOS?
Yeah. So, as I said, it started off as being able to stand up a bunch of zones and basically mock a distributed system on one machine. But what quickly happened is it turned into the ability to debug. So as I started learning dtrace, and that took a year, by the way. I think a lot of people get frustrated when they try to learn dtrace and they don't immediately get it. I think it's more than just learning dtrace, the language. You have to learn systems as well. But once I started understanding how to use dtrace and how to ask questions of my system, that's when I really got hooked. That's when I was like, I can't go back to Linux ever again, because at least at that time, ask any of these questions out of Linux. I wasn't able to say hook a probe on a kernel function and get a stack trace, right? Like something that is so simple in dtrace, that is dead simple. You couldn't do that a few years ago in Linux, or not very easily. That's changing, but you couldn't do it back then. So for me, I really think it was the focus on a coherent system, and a coherent system that you can debug, right? Frame pointers were always kept. On 64-bit systems, we always save the arguments to all the functions on the stack so that you have those. Post-mortem debugging is like a mandate in our system. We always try to have a crash dump when we do crash, when we panic, and always try to debug it. Having dtrace, obviously, and just all the tooling around being able to ask questions of my system and being able to understand the system versus what I've experienced in a lot of other shops, and especially when running on Linux, was, this thing failed, let's just change some tunables, or let's try this other config, or let's just restart it and see if something different happens, right? It was very ad hoc and very just lots of guessing. So I wasn't fond of that.
Restarting it is you throwing away all of that postmortem data, and now you can't figure out what happened.
Exactly. And yeah, and it's just a change of mindsets, I think. I think once you learn that, you really change your mind about things. Like I know there's a lot of people who they hear like, oh, like panic the system. They think that's something that never happened. You should try to avoid it as possible, when in reality, there's cases where the best thing to do is your system immediately, because you are maybe in danger of data on disk or corrupting some data in memory and maybe sending a bad response. Like there's lots of bad states you get into, and you want to understand why you're in the state, and nothing good can come out of moving on from the state. So you should immediately panic. You should take a core dump, and then you should analyze, hey, why did I get here, and how can we fix it? Because otherwise you're just silently doing bad things, and you don't know about it.
Yeah, it's kind of like you were saying. The CPUs, there's all these states we don't understand yet, and that's exactly what the panics in the kernel are for. The assertions and the invariants are, this is not a state we should be in. If we're ever in this state, we don't know what's going to happen. We need to stop here and figure out how we got in a state that doesn't make any sense.
Oh, absolutely. Yeah, I've definitely become very more assert and verify happy over the last couple of years. I try to assert everything I can. I've maybe even gone a little bit too far in a couple of cases, but yeah, and it was even more comical. I think Brian mentioned this on one of your episodes about the whole Linux change where they went from bug on to warn on, where it was, I think, instead of panicking, they just I think they just logged an error or something. And I thought that was just horrible, because there's a reason someone made this a bug on in the past. They decided this was a bad state to be in. So to change that willy-nilly across the board is just, I can't understand it.
Mm-hmm. Yep. So I'd say the reason I really am drawn towards Illumos and SmartOS is definitely the focus on just that, not doing stuff like that, on debugging your issues and understanding why things went wrong. Mm. Can you talk a bit about the shift from being an application developer to systems developer?
Yeah, so I'm trying to think, like, in terms of like how I specifically print. I mean, I guess I could talk about both.
Sorry, you're breaking up a little bit there.
Can you hear me now?
Yep. To clarify the question, I guess, a lot of people watching this podcast have some level of development. They build applications or whatever, but they're maybe interested in working on operating systems, and they're wondering how to kind of make the jump.
Yeah. It's a good question, and it's one I've definitely gotten a lot. And I mean, I think there's two parts to it. I think there's the general part where it has to be a mindset. Like, there's that saying where people say, I don't have time to do something. Well, you have the time. You didn't make it a priority. And I think that's just become more and more true as I've gotten older, and that if you think you want something, then that has to become a top priority or one of the top priorities. So if I would say to someone that wants to get started in it, you're going to have to make it a priority. You're going to have to spend some time on it where you might have done something else, where you might have watched that movie or gone out and done something or maybe hacked on something else. You're going to have to just spend some time just gritting your teeth and trying to figure things out. And it's going to be slow. I mean, I've been doing this for maybe 3.5 years now, and I just feel like I'm getting decent.
It's just scratching the surface.
Exactly. It's a very long, especially for someone, if you're like myself and you didn't actually study this at school. Like, I work with people who studied operating systems fairly deeply in school, like Brian Cantrell. That's what he went to school for. He learned about all that stuff from the get-go, whereas I didn't really get that. And so I've had to learn as I go. And that makes things a bit harder. But I would say to anyone who's in the same boat, like, you can totally do it. It's just the first thing you have to do is make it a priority. And then the second thing is the more technical part, and that is learning the technical things, like learning C, learning what all these different words mean, when you start talking about the kernel, because there's lots of them. There's lots of jargon, lots of acronyms, especially once you start looking at CPUs or stuff like that. And I wouldn't say there's any bad way to start. Like I could say, go read the System 5 ABI, or go read, the AMD 64 programming guide, or go read Solaris internals. Like any of those would probably be a good thing, because the system is so vast that just learning any of it is gonna kind of get you there. But I think for me, what really worked and what I think could really help is pick something you want to understand and just start trying to understand it. All right. So like one of the things I did is I would just pick things at random. Like I know I did a blog post on POSIX MQs that were added in, I think it was POSIX 1.4, whatever they called it. POSIX has like 5 different names for every standard. But whatever they added MQs, message queues at some point. And I was like, I just want to understand how this was implemented in Illumos. So I just, it actually probably took me an hour or so just to find the code, because I didn't know what the hell I was doing. And then once I found the code, it was a matter of reading the C. And I didn't know C back then. Like I learned C++ in college, but I didn't really like properly learn it. And I never really knew C. So I had to go and look at each statement in turn. Like, all right, here's a C statement. I have no idea what this means. Now I've got to go read some C books or go online and figure out, what does this one statement mean? And then I figure that out. It's like, all right, what does the next statement mean? Right. And so it's just that process. It's just a total grind, and you figure it out little by little. And then eventually things start to become automatic, and the things that you don't understand become more and more intricate. And you're able to more quickly go through stuff. So yeah, I think it's prioritize it, spend some time, and then really focus on one thing and try to figure it out. And you know what? If you do that for a few days and you get stuck, move on to something else, because you've definitely, even if you feel like you didn't figure it out, you learned something in the process of not figuring it out. So those are the 2 things I would recommend to anyone trying to make that switch. And then I guess the final thing I would say is you got to get yourself out in front of people at some point, right? You're not going to get this type of job just hoping that someone notices. You got to maybe try to commit some patches to FreeBSD or Lumos or Linux. And maybe write some blog posts, and maybe even try to give a talk about it. Maybe a Papers We Love or something like that, and just get some exposure, especially in front of the people that are already doing this. Because once you get their attention, then you've got your foot in the door. So,
yeah. Well, that's some very concrete advice, actually.
Well, even just blog posts while you're reading the code and learning it, just explaining it the way you now understand it, even if it's not everything. It helps not only you, but other people trying to go through the same adventure. I know there's a group of people on IRC reading a small bit of the OpenBSD code every day or every week or something like that, and just doing it kind of collaboratively and learning it that way.
That's actually a great point. And that's something I struggle with. I think a lot of people do, the blog post, right? It's like, okay, I'm going to read this thing and write a blog post about it. And then you start doing the blog post and you realize, well, I'm unsure about this detail. I'm unsure about that detail. I'm not going to put this out there. And I probably have a good 20 some blog posts just sitting in a graveyard on, in my Git stash, that, I probably should have just put out there, but I didn't want to, because I was afraid and that's something I agree. You shouldn't be afraid to put something out there that you're not 100% sure on, because it doesn't really matter at the end of the day. Everyone's going to get it wrong. Everyone writes bugs. That's another thing I've learned is, I work with some amazing kernel developers, and I know they're better than me, and that's okay. I'm learning from them, but even they are making mistakes and making bugs, because we all do. We're all human, and these systems are so complicated that no one's perfect. So I would agree. Definitely don't be afraid to put something wrong out there. Yeah.
Yeah, well, I think when I first became aware of you was actually when you wrote the Illumos syscall handler blog post explaining how that worked, and I found that very interesting.
Yeah, and I'm sure I got a detail or two wrong in there. I think I even, in one part of it, I'm like, I don't even know why the hell they did it this way. I don't know what this means, but I'm just going to push on, and I think that's probably the better way to do it. So yeah, and the thing is, I actually, I'm I'm doing this stuff now, but I actually wish I was writing more. I like to write those blog posts. It's been harder to find the time lately, but it's very fun. It is so much fun to crack open a piece of code and be like, all right, I am going to go through this line by line and figure it out and write something about it. I think that's a very enjoyable exercise. So,
in a structured way where you can like follow the thoughts, how you started with exploring it and then going through it, the code.
Yeah, and it leads you to so much other stuff. Like I said, at first you'll read a line of C and you're like, I have no idea what this means, and that'll lead you into all kinds of directions, right? You might C99 standard, the C11 standard if you want, and a little bit, and then you might like disassemble it and be like, oh, what does this assembly mean? And then next thing you know, you're in the Intel reference manuals, and you're learning how all that works. And so you can really take it as far as you want, and you can really learn a ton. And it's just a lot of fun.
Yep. So tell us a little bit about what you've been working on lately.
Yeah. So lately, I'd say probably the last year, I've been working on network-related stuff, primarily focused on making network performance a bit better in SmartOS and eventually Illumos. The code should get upstreamed at some point, but right now it's just SmartOS. But mostly what I've been spending time on is understanding our networking code in general, and then also trying to hardware classify some of the things, or hardware accelerate, depending on how you look at it. So in Triton, which is basically that's the cloud built on top of SmartOS, which we run in our public cloud and which people can run privately. In Triton, we make heavy use of virtual NICs, which are virtualized instances of a physical NIC, and we make use of VLANs, and we make use of link aggregations. And there's various things about those pieces that require software intervention in our networking stack, but don't necessarily need to. So there's things we can do to hand off some of the work to the NICs, such as like VLAN filtering. You can tell a NIC, hey, I care about this VLAN and I want you to send it to these queues when you receive traffic for this VLAN and this MAC address. So I've been looking at different things we can add in the hardware or in our networking stack to use more of the hardware, because as I was saying earlier, the NICs have become quite complicated, quite sophisticated, and there's lots of stuff that you can put into the hardware to kind of help accelerate the software side of things.
Mm-hmm. That kind of ties into our next question. You also did a bunch of work on VLAN hardware filtering.
So that's the first wave and that took a while because I was also trying to learn the whole networking subsystem at the same time. But yeah, basically what that allows us to do now is when we have what we call a VLAN vNIC, so that would be a virtual NIC with a VLAN attached to it. So all traffic that is sent out that vNIC gets a VLAN, gets tagged, and then it only receives traffic for that tag. So what I basically did is we currently need to software classify all VLAN traffic, or we used to need to software classify all VLAN traffic. And what I did was I added support to hardware classify on IXGBE parts, so 10 gig Intel parts, to hardware classify that traffic so that, for a given MAC address with a given tag, we can take that directly from the NIC and pass it up to the client that wants it, to the virtual NIC that wants it, without having to go through additional layers and say, oh, we got this VLAN, who does it belong to? Let's do a expensive lookup and then, pass that up. And it allows us to utilize some of our performance features in the networking stack, such as polling. So if a NIC is constantly receiving traffic, rather than just taking it all on interrupts, we will go ahead and switch the NIC into polling mode and pull the data directly off the rings. So basically, it opens us up to more performance when you're talking about VLAN traffic. And the work I did was for IXGBE, but we also have we're also going to implement it for Fortville, which is I40E. So those are the 10 gig and 40 gig parts. Although I think Fortville also has 25 gig parts. And then we're also looking at doing it for Chelsea parts. So I think the T4, T5, T6 line. So yeah.
Cool. So what do you think is the most valuable part of open source for you?
So this gets back to debugging. I think the most valuable thing about open source software is that if I'm having an issue, I can pull that code and I can try to figure it out on my own. I at least have a chance versus closed software. If there's an issue, I am at the mercy of the company. I'm at the mercy of the developers who work on it. I can't really do anything about it. So for me, it's all about being able to debug my software by being able to clone it and look at it. And I actually do this more and more as I gain more experience and as I get older. If I have an issue with another tool, like if I was having some issues with iPerf, and it's like, well, I need to go look and see exactly what iPerf is doing. And sure enough, I bring up the code, and I may not like the code I'm looking at, but I can at least read it and see, okay, iPerf is running this loop with non-blocking I/O, making these system calls, and this is why I'm seeing the thing I'm seeing. I think that's very important versus if I was using some proprietary benchmarking tool. I have no idea what it's doing. I could use certain tools on my system like dtrace and truss and such to figure out kind of what it's doing, but that's no replacement for being able to look at the complete code. And then on top of that, the other major thing about open source that I think is very important is that it gives you ownership, right? So one of the other reasons I love SmartOS and Illumos is I have patches in there now. I have ownership of this code. I'm a part of it. I can never get that with proprietary software, right? I like certain proprietary software, but I'm never going to feel like I'm a part of it, right? If something comes along that's better, I will easily drop it for that. Versus open source, I can contribute directly to it. I can have a stake in it. I can have a say in it, and I can feel a sense of ownership and pride in it, which I just don't see how you can ever have that in proprietary software. So.
Yeah, it's that feeling of pointing to something and saying, "See, this is what I made." And in a compiled binary in a commercial thing, it's hidden away somewhere.
Right. Oh, and that's another good point. Like, it is nice to be able to point people to commits and be like, "Hey, I did that. Like, I'm proud of this work, and check it out." Versus proprietary, you might have played a vital part in that product, but if you can't show it to people, kind of take some of the fun out of it, You want to show them like, hey, look at this code I wrote. This is awesome. So.
Yeah. So what do you think the most improvement in open source is needed? Whether it's technical or social or...
This is a really good question. And I feel like the answer I'm going to give isn't like, I feel like some better answer is going to hit me 2 weeks down the road. But I do think licensing is one of those things that is... I'm just more in dismay of it. I feel like there's too many arguments around licensing that are completely unproductive, and it prohibits us from sharing code that I think should have no problem being shared. And I think a good example is the whole ZFS CUDL versus GPL debacle, where the argument is ZFS can't be included in the Linux kernel because of the CUDL, and I don't think there's actually a problem there. But I'm not a lawyer, and even the lawyers don't agree on how it works, and it's just a shame to me. Now, granted, we do have ZFS on Linux, but I think we make it harder than it needs to be, and I don't get what the point of that is. Like I don't see how it helps us having these
disputes or these
barriers.
Meanwhile, in the other open source operating systems out there, the BSDs, we're happily using it for years now without having any issues. And that's certainly what you mentioned, the licensing being more problematic than helpful.
Right. So, yeah, and I don't have a good answer there. And I'm sure if there's any lawyers that end up watching this, they're shaking their head at me like, no, this is actually important and we need to have this. And there's a reason that, this conflict exists. But and I'm sure they're right to an extent. I understand that licenses are important, and we don't just want to, be willy-nilly about all that. But I just see a lot of strife and conflict over in areas where I feel like it's completely unproductive, and just to me doesn't make sense. So I don't know. I could just be naive, perhaps, but I feel like we could be better there, as a community or whatever you want to call it.
Certainly. Yeah.
So another question we like to ask is, what do you do for fun to avoid that burnout that you had before?
Yeah, well, it's very important to have something. I think that was part of the reason I burnt out at Basho when I was younger, because I spent all my time either at work or basically out drinking with friends. And that was kind of fun in my 20s, but that'll catch up with you really quick. And so I actually just recently moved a little over a year ago to Steamboat Springs, Colorado. And part of the reason I did that is because I wanted to spend more time outside and away from the computer when I wasn't working on stuff, right? And this is kind of a place kind of built for that. So I'm an avid snowboarder now. I think I have 38 days so far this season, and I actually feel like that number is kind of low because I've been a bit busier with work than planned this winter. But yeah, so I love snowboarding now. I got into CrossFit. How do you know if someone does CrossFit? They'll tell you. But I actually love it, and I think more people should try it. But I'm going to come off as that person, so I won't do that. But I love CrossFit, so that's what I do in the summer for fun. I love weightlifting, and then in the winter I snowboard. And so those two things really help keep me sane. And it has. I feel like I've not really come close to burnout again since I've decided to be more active outside of my computer work. And I think those two things help a lot. So,
yeah, to totally shift gears to get something else.
Oh yeah. Well, that's one of the reasons I love weightlifting is because anyone who's done this job long enough knows how pedantic we can all be and how much that'll drive you nuts when someone's being pedantic about something that you think is just so trivial and you just want to throw your computer out the fucking window. And so you need an outlet, and that's one of the reasons I love weightlifting, because literally you're picking up weights and then slamming them on the ground, and that just gets a lot of frustration out, and it's probably helped me avoid a lot of conflicts with coworkers just because I can go out and do that. So yeah.
Okay. Oh, that was a fun interview. But before we let you go, our last question is, do you have anything else you want to mention?
Yeah, just that if you're interested in SmartOS, I think, we've got some great commits coming down the pipe. Obviously, we did the Meltdown fix, which I guess isn't really a feature, but a necessity at this point. So, But I found that very exciting. I was basically just a cheerleader for that entire project because I was too busy with networking stuff. But I thought that was really cool to watch. And of course, there's the Beehive work, which I'm sure you guys are well aware of. You should definitely. I think you should definitely have someone else from Joint come on, like maybe Patrick Mooney, and come talk to you about that, because I think you could get a lot of good stuff there.
Okay, we're making notes.
Yeah, and yeah, I think there's going to be more network performance stuff coming down the pipe. So I think SmartOS is there's going to be a lot of interesting stuff. So if you're into that kind of thing, definitely follow it for next several weeks, because I think it's going to be exciting.
So, time for the news roundup this week. We have a certain John Carmack, which should be familiar to, I think, most of the gamers out there. He's been on a programming retreat to hermit coding with OpenBSD. Alan, take that away.
Yes. So for those who don't know, John Carmack was one of the people that wrote the original Doom and a bunch of those games of that type. Anyway, after a several-year gap, I finally took another weekend-long programming retreat where I got to work in hermit mode without other people around, away from the normal press of my work. My wife was gracious enough to offer it to me the last few years, but I'm generally bad at taking vacations from work. So, as a change of pace from current work on Oculus, I wanted to write some from-scratch C++ neural network implementations, and I wanted to do it in strictly the base OpenBSD system. Someone remarked that it was a pretty random pairing, but it worked out okay. Yeah, I don't know if neural network implementations in C++ and only a base install of OpenBSD are normally two things I put together. But despite not having actually used it, I had always been fond of the idea of OpenBSD, a relatively minimal and opinionated system with a cohesive vision and an emphasis on quality and craftsmanship. Linux is a lot of things, but cohesive isn't one of them. John says, I'm not a Unix geek. I get around okay, but I am mostly comfortable developing in Visual Studio on Windows. I thought a full week of immersive work in an old school Unix system would be interesting, even if it meant working at a slower pace. It was sort of an adventure in retro computing. This was FVWM and VI, not Vim, but actual BSD VI. In the end, I didn't actually explore the system all that much, with 95% of my time is just the basic VI make GDB operations. I appreciated the good man pages, and I tried to do everything within the self-contained system without resorting to internet searches. Seeing references to 30-plus-year-old things like Tektronix terminals was very amusing. I was a little surprised that the C++ support wasn't very good. G++ didn't support C++11, and LLVM C++ didn't play nice with GDB. GDB crashed on me a lot as well, and I suspect due to C++ issues. I know you can get more recent versions through ports, but I stuck with what was in the base system. In hindsight, I should have gone full retro and done something in ANSI C. I do have plenty of days where, like many older programmers, I think maybe C++ isn't as much of a net positive as we assume. There's still much that I like, but it's a relationship or a hardship for me to build small projects in plain C. Maybe next time I do this, I'll go full Emacs, another major culture that I don't much exposure to. I have a decent overview understanding of most machine learning algorithms, and I've done some linear classifiers and decision tree work, but for some reason I have avoided neural networks. On some level, I suspect that deep learning being so trendy tweaked a little bit of the contrarian in me, and I still have a little bit of a reflexive bias against throw everything in the neural network and let it sort it out. In the spirit of retro theme, I had printed out several of Jan LeCun's old pages and was considering doing everything completely offline, as if it was actually in a mountain cabin somewhere. But I wound up watching a lot of the Stanford CS231N lectures on YouTube and found them really valuable. Watching lecture videos is something that I rarely do. It is normally hard for me to feel the time is justified. But on a retreat, it was great. I do think, if anything, particularly insightful to add to neural networks, but it was a very productive week for me, solidifying book knowledge into real experience. I used a common pattern for me, get first results with hacky code, then write a brand new and clean implementation with the lessons learned, so they both exist and can be cross-checked. I initially got backprop wrong both times. Comparison with numerical differentiation was critical. It is interesting that things still train even when various parts are pretty wrong. As long as the sign is right most of the time, progress is often made. I was pretty happy with the multi-layer neural network code. I wound up in a form that I can just drop it into future efforts. Yes, for anything serious, I should use an established library, but there's a lot of times where you have a single CPP and H file that you just wrote, and it's convenient. My converged network code just got to the hacky but working phase. I could have used another day or two to make a clean and flexible implementation. One thing I found interesting is that when testing on minst with my initial neural network before adding any convolutions, I was getting significantly better results than the non-convolutional neural network reported in comparison to LeCun's 1998. Right around 2% error on the test set with a single 100-node hidden layer versus 3% for both wider and deeper nets back then. I attribute this to the modern best practices using RELU, softmax, and better initialization. This is one of the most fascinating things about neural network work. It is all so simple, and the breakthrough advances are often things that can be experienced with just a few lines of code. It feels like there are some similarities with ray tracing and graphics work, where you are implementing a physically based light transport ray tracer quite quickly and produce a state-in-the-art images as if you had data through the runtime. Anyway, I got a much better gut-level understanding of overtraining, generalization, and regularization by exploring a bunch of training parameters. On the last night before I head home, I froze the architecture and started playing with hyperparameters. Training is definitely worse than compiling for staying focused. Now I get to keep my eyes open for work opportunities to use these new skills. I am dreading what my email and workspace are going to look like when I get back to the office tomorrow.
Yeah. Well, that's certainly interesting. Yeah, I mean, I haven't dabbled much with neural nets, but the training part is important because otherwise it outputs nothing valuable, and the training keeps a lot of time to get it right. And then the network does actually do good work, or can do a good amount of work because it's been trained properly. Okay, the other sponsors we have for this week on the show is DigitalOcean. Head over to DigitalOcean and check out what they have in store for you, because they provide you with virtual memory, not virtual memory. Well, yeah, it's also virtual, but they provide you with virtual systems, of course, that have also memory. These little systems are called droplets in their terminology, and it's quite easy to start them because it only basically requires you to select which kind of instance type you want, and within seconds it will spin up and you can start it right away.
Yeah, and if you were just looking at that OpenBSD mail server tutorial and like, hey, I like that. Well, with their 1 gigabyte droplet, you get twice as much memory as you need. You have the option of using FreeBSD and ZFS, or we have a tutorial somewhere buried about actually installing OpenBSD on a droplet if you want to do that. And you got 25 gigabytes of SSD, so you get that little bit more breathing room on space. A terabyte of internet transfer, which you're going to struggle to use up with email. And it's just $5 a month or 0.7 cents per hour.
Yeah, they also provide you with a nice management interface. They give you a little bit of traffic analysis, or show you what this little droplet of yours is doing currently. Is it more chugging on CPU? Is it using more memory? Or is it just pushing packets around? So this is what the web interface will also show you without having anything extra to install. So normally to get to the console for many of these other systems, you need to have some kind of Java plugin or something. Not in DigitalOcean. In DigitalOcean, you open it with just a click, and it's a nice HTML5 GUI, I think, and it will open seamlessly, and you can use it and connect to your droplet in case you lost network connectivity or some other thing, or you want to do something.
If you want to replace the operating system that comes in the droplet with OpenBSD.
Yeah, single user mode is possible this way, and it also has team functionality, so you can add a bunch of friends to help you manage that system or multiple of these droplets.
Yeah. Your mail server might be for work, or you need to have someone else have access to your mail server. It makes it super easy. They can get in there and do stuff and start up the backup MX or whatever, and not have access to your credit card. And with DigitalOcean, they have lots of locations, so you can put your backup MX in a completely different data center or in a completely different country. With your choice between San Francisco, Toronto, New York, London, Frankfurt, Amsterdam, Bangalore, or Singapore. I think I got all of them. You can just put the backup and the primary mail servers wherever you want.
Yeah, close to you or where your customers are, and then they get the decent performance without having to travel with the packages half around the world.
Plus, you have the built-in snapshot feature, so you can snapshot a whole VM and pay a discounted rate for storage, or you can also use their backup feature to back up a whole machine. So that, combined with replication and having multiple data centers and so on, means you can just have it just work, and it only costs $5.
Yeah, and definitely use the coupon code FreeBSD Now, and that gives you a $10 credit to your first little instance that you can start and stop it whenever you want and delete it, and you only get billed for that specific amount of usage time.
Yes, and the best part is all droplets at DigitalOcean are always billed hourly. You always actually pay the hourly price. They just cap the price at 28 days per month. So, if you use it for the whole month, you pay the flat fee so that you don't get a slightly different bill each month depending on how many days were in the month. But it does mean that if you sign up right now, where it's March 21st, your bill at the end of March will only be for the 10 or so days that are left in March. And so you will pay exactly the number of hours you had the instance running for in March, not the whole month.
That's what most people need to try out certain things, and then either they like it and continue, or they drop it and then use something else, or start another VM with a bit more memory or whatever.
Yep. And
all right,
with the flexible droplets, the best part is you can actually, with just a reboot, switch between the 3 different sizes. Like, I need more RAM. Oh, I've changed my mind. I want more CPU. Oh, I need to build both. Reboot. Now I'm on the middle one. Boom. Problem solved.
Yeah, definitely give them a try, and use our coupon code FreeBSD Now. Okay, our next story is about stack register checking. This is over at undeadly.org, which means it's OpenBSD related, of course. And it starts with that recently Theo de Rat, of course, described a new type of mitigation he has been working on together with Stefan Kempf, which is Stefan at openbsd.org. So they were thinking, how about we add another new permission? This is not a hardware permission, but a software permission. It is opportunistically enforced by the kernel. The permission is map_stack. If you want to use memory as a stack, you must mmap it with the flag bit. The kernel does so automatically for the stack region of a process's stack. 2 other types of stack occur: thread stacks and alternate signal stacks. Those are handled in clever ways. When a system call happens, we check if the stack pointer register points to such a page, and if it doesn't, the program is killed. We have tightened the API. You may no longer point your stack register of non-stack memory. You'll be killed. This checking code is MI, so it works for all platforms. So this is pretty much machine independent of that. Yeah, machine independent, definitely. And so by using OpenBSD on different platforms and using that feature when it comes out, or if it's already there, then you definitely get the benefits of that. This is now available in snapshots, and you can find more details in our show notes, of course. It's available in snapshots, and people are finding the first problems in the port tree already. So far, a few issues have been uncovered, but as Theo points out, more testing is necessary. And here we have a quote. Fairly good results. A total of 4 problems have been found so far. Go SBCL in 2 cases in source/regress, which failed the new page alignment requirement. The SBCL and Go ones were found at build time, and since they used themselves to complete the build, that's pretty much the compile time when they discovered that. More page alignment violations may be found in ports at runtime, and this is something he worries about a bit, so he asks everyone to try out and help out where they can. Use the snapshots, which contain the stack check diff, update to new packages, and test all possible packages. Really need a lot of testing for this, so please help out. And definitely install the latest snapshot and try out your favorite ports. And the more people do this, the more stuff they find and can fix that, and which is in time to report issues where you can report them to OpenBSD in the usual way. And there's a good chance that this additional security feature is present in the 6.3 release. So this is upcoming soon enough and works with third-party software from packages. So we'll keep an eye on that. It certainly looks interesting.
Next up, we have Nomad Bsd.
Ooh.
Which is basically a live USB stick version of FreeBSD 11.
Which is...
So it's just hit 1.0. And it comes with quite a bit of useful stuff on a USB stick.
So this would be something I would...
Screenshots.
Yeah, so this would be something I would take to a computer store when I'm in the market for a new laptop to try out whether BSD works on that good enough.
Yeah, but it's also useful if you just need to run some applications or whatever. So they've improved the setup process a bunch. They now support optional GELI encryption for the home partition so that you can have persistent data that's actually encrypted. They now auto-detect NVIDIA graphics cards and load the right driver, especially if it's an older machine. It might have a graphics card old enough that it needs a different version of the NVIDIA driver. There's now a RC script to start the disk scheduler on the root device, and they've added more software by default so that most of what you're looking for will be there, so you don't have to package install it or whatever. Including adding Redshift so that your screen will look nice, Kantata, a music player, FileZilla, BSD Tetris, a NeoMut Mill client, a calculator.
Yeah, this is useful.
Torrent client, BSD Stats, lockout tools, and a bunch of other things. I can see they have LibreOffice and stuff on there, web browsers, all that kind of stuff, so that you can just have a useful system you can work on without actually touching the computer. Very handy if you need to have a BSD system with a graphical interface and a couple things to fix somebody's computer or to do something or work on a borrowed computer, or, like you said, great for testing in the at a computer store as well. They fixed a number of issues, including applying the Lenovo fix stuff so that the X220s will boot this properly in the default image, and disabled the terminal bell so you don't end up going ding, ding, ding at the computer.
Each time you tap.
Yep. But yes, it looks pretty nice.
Oh, they even mentioned our show in the press section down there.
Yes, because we had talked about it a little bit before, a while back, before they got version 1.0. And
okay.
They have a GitHub if you'd like to suggest making certain changes to it or whatever. It's all there.
Cool. Nice. Here you're in the market for a new laptop, or a new one is arriving soon. So
Yes,
yeah,
so
you might try this
I
out.
ordered my new X270, but it won't ship until next week. I'm sure we'll talk about that more once I have it in my hands.
Yeah, first-hand experience. Okay.
But I'm kind of torn on that one, whether it'll run head or maybe 11 stable.
Depends on what you're using.
Even
it
if I
for.
go with 11, it now has all the new graphic stuff and it'll just work, and maybe that's better. But, I generally just run head on everything.
Yep. Okay, people check that out, and give them some feedback, whether you like it or not. So, time for the Beastie Bits section of this week. First item is the Knox bug here, the BSD user group, of course, and Knoxville. And there's a meeting coming up Tuesday, March 27, with John Hickson presenting about Nagios.
And as a deviation from normal, this will not be at the library where they normally hold this. This will actually be at the IX Systems office there. So there's a map if you're interested, and the parking's available at the parking garage across the street, or just around the sides of the building.
Oh, very nice. Yeah, so if you're interested in John Hickson's presentation about Nagios, definitely, if you're in the area, of course, and can reach that, then check it out.
Then, big news, the videos from VBSDCon, which was last September, are now online. You can check out the various talks. Watch out that the list does have the ones from 2015 mixed in, but they're later in the list. So the top of the list is the new stuff. And it's worth checking out.
Yeah, there were a bunch of good presentations, except mine, of course. There were some good ones, and I'm trying to watch some of those I missed somehow, either due to hallway track or being in another talk. So that's definitely something people can watch who couldn't make the conference.
Yes, and as promised last week, all the videos from Asia BSDCon 2017 are now up, which adds up to an impressive 34 videos.
Yeah, that's a long list to watch.
A lot of content. I've noticed some people have already been watching things. I've started getting questions about my presentation at it via email just in a couple days since I posted these. And next week we have the 2018 videos up. So we finally.
So you have to watch those by next week.
Yes. So while we give you a week between when we posted 2016 and 2017, now you have a week to watch 34 hours of video, approximately. It's not actually quite that much, but 34 videos in time for us to land all the 2018 videos.
Yeah, so pick and choose a couple of those to watch later, maybe, and to keep up with
There were a bunch of these that I didn't get to see because I was busy, giving my own talk when there was 2 other talks going on at the same time, or attending one of the talks and there were 2 I wanted to see, and so on.
Yeah, check out the list and comment maybe on some of those and which ones you like. And it actually contains a bunch of good stuff about BSDs that's been going on. Next up is a Dragonfly BSD adds new PTR restrict security option. So just like the Linux developers, it's a short and sweet bit over at Phoronix. In the wake of the Spectre and Meltdown CPU vulnerabilities, Dragonfly BSD developers also have been working on a variety of security improvements. Dragonfly BSD has already pushed Meltdown fixes and Spectre mitigation, while the latest security work on this BSD operating system is a new security.ptr_restrict sysctl option. And when that's enabled, another small safeguard that aims to prevent leaking kernel addresses back to user space is applied, and that's the gist of the outlined the linked commit there, hitting the Dragonfly BSD tree today.
I have to look into that more. The commit is not very detailed.
More backdoor mitigations is always good to have. All right, next up is a call for help because Mr. Dexter needs your help. We have a little tweet from him here asking, does someone have an insane amount of CPUs running FreeBSD that he can borrow? He won't break it. He will be careful. Maybe. Yes, he's aware of Q, our very own show notes editor every week. He has a bunch of, or one big system that has a lot of CPUs.
Yes,
maybe someone
JT's problem is that running that system for too long pops a breaker in his garage.
Yeah. It's not a data center environment.
Yeah, what Dexter's working on is expanding the build option survey. So in FreeBSD, there are many of these flags you can turn on and off to say, don't compile sendmail as part of FreeBSD. And a lot of those work, but what happens when you combine different combinations and such? And so there's a script originally written by Paul Henningkamp and then later updated by Bjorn Zeeb and then later worked on a bit by Brian Drury. And Dexter's now working on that and running the results and seeing, hey, if you don't install a toolchain at all, don't provide a compiler, you save like 150 megabytes of the base image and so on.
Yep, so that way we know how to build a very small system that has still some essential stuff on it. And
it's also, he's found a bunch of accidental build errors. I remember seeing one where if you told it not to compile OpenSSL, then this other thing that depended on OpenSSL would just not build or cause an error. It didn't say, I should not build that thing that needs SSL. It would try to build it and be like, I can't find the SSL files. And a bunch of things like that. So he's already finding some minor bugs, mostly just options that weren't carried out quite right, but also some options that don't make sense because it's not possible to build a useful system without it, and so on.
Okay. Yeah, if you're capable of helping out, then reach out to Michael Dexter. and hopefully we'll see some results from that. Next up, this sounds familiar from last week, but we can't mention it enough. Mike Larkin was at BHAVCon 2018 with a very impressive presentation of OpenBSD's VMM, basically showing us migration in one way or the other.
It was mostly just what has changed in VMM in the last year. So if you're wondering what's up with that, there's slides.
Yep, PDFs, and that's giving you an idea what's been happening since last year. And last but not least, we have a heads up, OEF-ED and RDMA stack updates.
Yes, so this is the OFED is the, what is that?
Fiber channel? Yeah.
Something like that.
And what's RDMA?
InfiniBand.
Yeah, stuff. Right. Those two.
So it's also the basis for some of the Mellanox network cards. So if you're like me and bought a bunch of those old Mellanox ConnectX 2s on eBay for like $15 a piece and put 10 gig in all your servers, this impacts you. And you should definitely make sure that all of this still works on your old cards and so on.
Oh, yeah. It's always good to have people working on this because it's a technology we can't completely ignore. So
yes. Plus, if you actually use RDMA, which is remote DMA, direct memory access, or OFED, then this probably impacts you as well.
Yeah, and you should try out whether it gives you a bunch more features or security boost, not security boost, performance boost, one way or the other.
Yep. And then the feedback section of today's episode is brought to you by Tarsnap. Head over to tarsnap.com/BSD Now and start doing your backups. Why haven't you started already?
Yeah, it can crash and burn every second without backups.
If you don't have at least 3 copies of it and some of it's offsite in a different format than where you're storing it, your files don't really exist. It's just an illusion. So if you would like your files to continue to exist, you should have a backup at Tarsnap, in addition to other copies elsewhere.
Yeah, especially the important files like text files or some other documents that you don't want to lose. You certainly should back them up. But where should you back them up? In a place that has a lot of storage space, but only you are able to access those because you are the person holding the key.
Generally, the problem that you would have with backing up to the cloud is now your files are just out there for somebody to accidentally goof a permission or something. But with Tarsnap, because it's backups for the truly paranoid, all your data is encrypted with your key before it goes to the cloud. That way, no matter what the cloud does with it, no matter who breaks into the cloud, no matter which government twists the arm of the cloud, nobody can read your data. Only you have the key. As long as you take care of the key, your data is recoverable by you and only you.
Yeah. So give it a try and use one of the clients provided. But basically, if you know how to use tar, then Tarsnap should be very familiar to you.
Yep. And if not, there's also the Tarsnap Mastery book, which will cover more than just how to use it, but how to use it correctly and how to build a backup scheme that makes sense to you.
Yeah. Even long-time Tarsnap users might find something new in there.
Yes, I've been a long-time Tarsnap user, but it's mostly been a kind of, hey, back up twice a day.
just to be sleeping better at night.
And because of the deduplication feature, I don't have to worry about getting rid of an old backup or something because I'm using like no space. Because while the files, I add new files, I don't generally change old files very much. And if I do, because of the special block level deduplication. So Tarsnap uses an algorithm Colin came up with to do dynamic block sizes. So rather than having fixed blocks where I make a change and it might affect 2 or 3 blocks in the file and cause me to back up all of those, Tarsnap heuristically detects the natural blocks in the file and can actually isolate changes better. And using that, provide even better deduplication.
See? Yeah, that's very, very important as the more files you have or the more they change. Yeah, so check out Tarsnap and start backing up your files. Okay, the feedback and questions that we got for this week starts with Ron with a request to interview someone using Dragonfly BSD. He writes, in a recent episode, you interviewed someone who uses Dragonfly BSD as his daily driver. I guess that was our architect chat member. Anyway, he went back through the last few episodes and could not find that interview. He's interested in contacting him since he's heading in that same direction. He just wanted to pick his brain on some of the pitfalls he overcame in setting up Dragonfly on his primary desktop. He's not sure if we can send him a mail, but we have the chat open right now. But if you can forward this to him, and I will wait for him to reach out to him if he is interested. Yeah, thank you. Yeah, we'll make the connection to you, and that you both can talk more about Dragonfly BSD and setting that up. That's certainly possible. He's hanging out in the Jupiter Broadcasting chat, typically during the show time. I guess that's all we have to add to that one. It's short and sweet, but definitely connect with people that are using your same operating system.
I think that was just a few more weeks ago than you were thinking. I think we have an email address for him in the show notes from that episode as well.
Yep. Then you have a way to contact that person and get starting to Dragonfly BSD the whole time. Yeah. Thanks for sending that question. Next up is Brad about gaming and all. This is always coming up here and there. He writes, didn't realize you guys were gamers. He found another source of games that I played when he was younger. Apparently, there's a number of sites that carry abandonware, usually DOS games based on it phenomenally, or that run phenomenally in DOSBox, which is good because he has an abysmal luck with getting more modern games like StarCraft and StarCraft 2 to work in Wine. Anyway, here are a few of the abandonware sites. Yeah, they're linked in the request or in the show notes. I've always said that because they didn't have the graphics back then, they had to make the games interesting and compelling. Yes, stuff like Tracon, which is an air traffic control sim, and Harpoon, a naval combat sim. I haven't never played those. I need to.
I've heard of Harpoon, but never played it.
Mm. So, do you all have Wine running reliably on BSD? I'm running TrueOS, he says, and have had little to no luck with anything he has tried.
I've not tried to run Wine on FreeBSD in a very long time. I might have to look into it a bit more, but yeah, I don't really game much anymore.
Yeah, certainly. It's been a gaming less year already for me. But with virtualization catching up with the graphics soon, maybe some of the older graphics might run, as long as they're not too GPU intensive.
Yeah,
maybe it will work. But these old games like DOSBox, definitely DOSBox works great on FreeBSD and other systems. So that's for the old nostalgia here and there, the little gaming.
Yeah. I'm sure some people have Wine running on TrueOS, so maybe somebody knows more that they can let us know.
Yeah. Send us something in, and we'll cover it in the show for all the gamers. And maybe Beehive in the future will be able to get a little bit better in the graphics department. So
well, pass-through apparently is coming. I don't know. We'll see.
Okay, but definitely thanks for sending that question. Next up is Muhammad about sockets versus TCP. So he writes, "Hi guys, as always, thank you for the awesome work you do. Please keep it up." Sure, we'll do. With that feedback, that's certainly a continuation of the show. He writes, "I've been a FreeBSD user for 10 years now. It's my go-to operating system, especially for a PHP web stack. He's been using FreeBSD, Nginx, PHP, and MariaDB for a long time without any issues. Lately, however, he's been facing an issue with one of his customers. So they have 3 websites which they use to run with 8 DigitalOcean Linux droplets, an Nginx load balancer, plus 6 Nginx PHP nodes, plus a node from MySQL and Redis. He switched them over to 2 big droplets running FreeBSD and splitting things up into jails. Nginx communicates with PHP through Unix sockets, which is a fast CGI pass-through, and everything runs smoothly except that they run a poll when they have thousands of their readers vote at the same time, and he starts getting connection issues like connection failed or operation not permitted. Switching the connectivity between Nginx and PHP to TCP, which is fast CGI pass with the actual IP address rather than the Unix domain socket, makes the site handle much higher loads. Knowing that Nginx supports much higher traffic than what he's getting, he guesses that it's an issue of a tunable, and maybe we can shed some light on that.
I don't know if you have like what you have as far as control for a listen backlog on a Unix socket. I've mostly used TCP sockets like that because I've had many machines running. So I've the PHP executes in a jail, but there are 5 jails that are on different machines than the Nginx that's doing the work. So I've not done that much with sockets under high load, with Unix domain sockets under high load. I don't know what level of control you have for backlog and so on.
Yeah, he mentions a load balancer, but that's what Nginx is doing. But thousands of people voting at the same time. That's some like PHP voting.
Right. So the bigger problem he's having is the backend's not keeping up, and so connections are queuing up, and then the Unix socket is dropping it. Whereas with TCP, because you have a listen backlog, so incoming connections that the kernel has accepted, but the application hasn't got to yet, allows it to buffer the big swarm coming in.
That's the
part of it. It would also be when that's happening, looking at, are your PHP FPM processes maxed out, or are you not getting enough throughput? But maybe somebody else knows about controlling the listen backlog or queue on Unix domain sockets. Of course, if TCP is working, that works nice as well. You just might want to create a virtual interface with unroutable addresses to put the stuff on, because listening on 127.0.0.1 in a jail, we use the jail's primary IP, which, depending on your setup, might be external.
Yep. Or you have a way to put that specific voting part somewhere else on some external service, maybe, so that you pretty much redirect the traffic away from your site just for this voting. I don't know, but I think BSD has the capability of handling all that traffic. It's just a matter of...
Right, it's just a matter of the Unix domain socket. The PHP FPM process listening on the domain socket isn't answering fast enough.
Well, that's an interesting problem, actually. It would be nice to run dtrace on that and see where all this is ending up, or where the performance is lost.
I just don't know the tunable off the top of my head because I don't use Unix domain sockets very much.
Yeah, but maybe someone writes in and finds that for us. But it's great to see that you're using FreeBSD for so long, and besides that issue, keeps you pretty happy with that, and you can run the service this way. Very nice. And last but not least is Paul. He has all, or at least most, of Brian Cantrell's talks. So he writes...
Yes, I think we already covered this previously, but in case you haven't heard, Brian has, on his blog, gathered all the talks he's given in recent memory, basically.
Categorized.
Each one has a little overview of what it's about. And then at the bottom... inspired by some trilogy of his that happened one time, he's broken them up into trilogies about different things, including software values, debugging, technologies that are beloved, about open source itself, about containers, about dtrace, and one that's just lightning talks.
Yeah, so definitely... rewatch those Cantrell talks. They still are relatively up to the point, and of course up to the times that we still live in. And he has certainly some good points to mention.
Yep.
All right. That's it for this week. Thanks for all your questions. Thanks for your interest in this show. And again, if you have anything that's BSD related found on the internet, then send it to us at feedback@bsdnow.tv.